Hello, I'm Richard Hooper, and today I'm pleased to be joined by Rob Hoyt, President and co-founder of Tethers Unlimited. Now, Rob, can you tell me a little bit more about the history of Tethers and how it was formed?
Back in 1992, when I was in graduate school at the University of Washington, one of my favorite science fiction authors, Robert L. Forward, came to the school to give a talk about the work he was doing with NASA developing applications for a technology called space tethers. And he talked about all the cool things you can do with tethers. But at the end of his talk, he said something like, but none of this will work because space tethers will get cut by space debris. And he hinted that he might have some funding to support a student to help him work on that problem. And this was when I was supposed to be studying for my qualifying exam. So to procrastinate that, I went home and uh, played around on my old Mac Plus and developed a program to look at the problem and came up with some potential solutions and sent off a letter to Bob Forward. And a few weeks later, he called me up and said, "Well, I think you've already done my project for me." So he at that time he hired me as a consultant for his old consulting company. We worked together for a few months on it, and then I went off to Los Alamos to do my PhD research. As I was finishing that up in 1994, we saw that there was a NASA Small Business Innovation Research, or SBIR, solicitation that mentioned space tethers, and we decided to form a partnership and go after and submit a proposal. And then a couple weeks before I was graduating, with no job lined up, we ended up winning a phase one SBIR contract. So a few days after I graduated, we went and formed the company and got going on the NASA contract, and I've never had to get a real job since.
Well, that's quite interesting, but you must have faced some big challenges as you were negotiating through that. How did you navigate them?
Well, when I started off working with Bob, I was a fresh out physics and engineering major, and looking back, I really had no idea what I was getting myself into. Really had no idea how to run a company. So I can say I've learned a lot of stuff the hard way about running a company. Worked with Bob for a few years, and then 2001 he turned 70 and decided to more or less retire. And at that point, I took over running the company, and it's been an interesting journey. We were very focused on that one technology, space tethers, and we learned the hard way that it was not a great idea to be so focused on one technology and one customer, because funding for space tethers is very very inconsistent. But fortunately, during one of the kind of downturns in space tether funding, we were able to find some other work to keep us going, and we made a concerted effort to diversify our technology base and diversify our customer base, and that has stood us pretty well over the years, as we've been able to maintain fairly steady growth over that time, even as technologies come in and out of favor and customers, you know, wax and wane in terms of their level of funding for research and development. So we branched out into several related areas. We've done a lot of work on advanced technologies for small satellites, and that's now our biggest sales area. And we've also done a lot of work on robotics and other technologies to enable in-space services, such as robotic assembly of spacecraft, servicing, and in-space manufacturing. I think the main thing we've done is that's enabled us to be successful is we didn't follow the conventional startup wisdom of staying laser focused on one technology. We broadened our focus, and tried to build up an organization that had a number of different products, a number of different technology areas, so we could keep building the company's capabilities, building our staff, building our revenue, but have flexibility to pivot into different areas as the market conditions evolved.
Now, you say that about moving around and transitioning, but that leads me straight into the bit about the legacy satellites for the 21st century, because you're involved in transitioning those, aren't you?
Yeah, a lot of our research and development right now focuses around enabling robotic assembly, servicing, and upgrading of spacecraft that are in orbit. So instead of having to build the whole satellite here on the ground and enable it to survive the 10 minutes of assault and battery it experiences during launch, we instead want to enable satellite operators to launch small, rugged packages that a robotic system can assemble on orbit to make the full functioning spacecraft, and then enable those systems to be serviced, refueled, and upgraded over time. In part because one of the challenges the space industry is experiencing right now, particularly the geo communications satellite industry, is those satellites typically are very large, very expensive, and take a long time to build, and take an even longer time, 10 to 15, being able to generate enough revenue to pay back the investment and make some level of profit on what was put into building those satellites. And the challenge is that the markets and technology here on the surface of the Earth are evolving much more rapidly, so that within 5 to 10 years, the satellite technology is out of date, and a lot of the geo satellite operators are really struggling to stay competitive and even stay in business as the terrestrial market evolves. So the approach we're pursuing is to enable these communication satellites and other spacecraft to be launched in smaller modular components, and then, as I said, assembled on orbit, and enable them to be upgraded every few years with new technology, so that so the satellites can evolve to match the changing market needs and changing market opportunities.
So, with regards to the robotics, you're heavily involved in that. How has the development advanced your business mission?
Well, we've initially gotten started by working on the key components needed to enable small, affordable spacecraft to perform these in-space servicing missions. So we've been developing technologies such as a compact, low-cost robotic arm, which we call the Kraken, that will enable satellites as small as nanosats, kind of microwave oven-sized satellites, enable those to perform missions such as assembling several modules together, or servicing a spacecraft that might have a stuck solar array or other deployment failure, and then enabling those small, affordable robotic spacecraft to upgrade other satellites, such as bring up a new transponder with new technology and higher performance, and integrate it onto an existing satellite. So that work right now is still in the early R&D stage. We are starting to put together and prepare to fly demonstration missions to start proving out those technologies, and getting flight heritage for them, so that they can be adopted into the critical path for operational missions. So that part of that work has enabled us to expand our focus and get established as one of the leading companies developing new capabilities for in-space services.
Now, it's interesting, when you first started, you were heavily involved, it was space debris. You evolved to where you are now, but of course space debris is still there. It's a critical issue. So
Yep.
Tether's involvement, what is it now with regard to space debris?
So we started working on solutions for end-of-life disposal of satellites and active removal of space debris 25 years ago under some NASA SBIR funding as well as DARPA seedling investments. Unfortunately, we were 25 years ahead of the market. And back at that time, although we were successful in bringing in some R&D funding, we weren't successful in actually transitioning those technologies uh, to sales and commercial applications. So we never really gave up on those technologies, but we recognize that back at that time there were really no requirements or enforcement for debris mitigation. So we realized the time just wasn't right, and we put those technologies on the shelf and worked on other things for 15, 20 years. But within the last 5 years or so, the debris problem has gained much more prominence and attention within the industry, and we brought some of that technology back out and dusted it off, and actually developed some new improved versions of it to better address the opportunities in the market. And then, in the last few years, we've had success at actually selling and getting some of those products on orbit. So now we have a handful of our deorbit devices, which are called Terminator tapes, that are on orbit. And one of them actually was activated back in September. And by looking at the tracking data for the satellite, we can see that it's actually working and dragging the satellite down out of orbit. So it's a case where, 25 years ago, we saw that there was going to be a problem. We had the foresight to do that, but we didn't have the right timing of the market. But fortunately, we had the persistence, and were able to, keep going, working on other stuff, and then we were ready for the opportunity when it arose.
Now, you're clearly a company based on innovation. So what's the most exciting thing you're working on at the moment?
There are a lot of things I'm really excited about. One of them is uh, a demonstration mission that we're putting together called MakerSat. And it's an experiment that will fly on the Restore-L mission that NASA is going to launch in 2022. And the MakerSat is part of a larger demonstration of in-space servicing, in-space assembly, and our focus is in-space manufacturing. So MakerSat is going to manufacture a 10 to 20 meter long high-performance carbon fiber boom on orbit. So essentially what we're doing is demonstrating that we can manufacture 2x4s on orbit that future robotic space systems can use to assemble very large structures and other components on orbit. So we can do things like build giant telescopes to enable NASA to get to detect and get pictures of planets around other stars, enable NASA and the DoD and other customers to build giant antennas to improve communication capabilities, and enable NASA and commercial space to start building large habitats and other systems to support mankind's expansion out into the solar system.
Well, exciting times, Rob. Sounds very interesting. Thank you for talking to us.
Okay, thank you.